Florida Today and FloridaToday.com are proud to bring you Saving Hubble, a special presentation about NASA's Hubble Space Telescope mission, which is scheduled to launch from Kennedy Space Center later this month.
The Hubble Space Telescope. Notorious for its phoenix-like rise from fabulous failure, NASA's flagship observatory now is regarded as the most productive scientific instrument ever designed by human engineers, the most important telescope ever launched into orbit. A cosmic time machine, Hubble was launched back in 1990 with a misshapen primary mirror, and its view of the universe was fuzzy as a result. It was as nearsighted as Mr. Magoo. But spacewalking astronauts fixed the telescope during a dramatic repair mission 3 years later, and the observatory since has revolutionized our understanding of our solar system and the universe. Now NASA is poised to send up another 7 astronauts on a 5th and final Hubble servicing flight, a mission to install 2 new state-of-the-art science instruments, repair 2 others, and equip the observatory to operate another 5 to 10 years. Hubble scientists are understandably stoked.
I am on the highest peak I've ever been on, personally or professionally. Hubble is going to be 10s and 20s and 30s of times more capable than it has been up to this time. We're going to look farther back in time than Hubble has ever looked before. We hope to look to within 400 or 500 million years of the Big Bang itself. Right now, the farthest Hubble has looked back, we have one object that we have detected that we believe emitted its light when the universe was about 800 million years old. We have hundreds of objects that emitted their light when the universe was about 1 billion years old. We want to push back farther in time because what we're seeing are the little fledgling infant galaxies just starting to form, little clumps of stars and material that later will come together and collide and build bigger structures like we're accustomed to seeing with our own Milky Way galaxy, for example. And today we realize how little we know. I mean, it's becoming almost a cliche that we only understand about 4% of the content of the universe, which happens to be the 4% that contributes to who we are. But the other 96% remains a deep mystery.
Who was Hubble? Born in Missouri in 1889, Edwin Hubble was a Rhodes Scholar and astronomer who in the 1920s made the discovery that our universe is expanding. His observations revolutionized astronomy, and he stated that there are other galaxies in the universe besides our own, and the universe in fact is expanding. His work gave birth to the Big Bang Theory. He died in 1953. Ever since Hubble realized that galaxies were rushing away from each other, astronomers have sought a precise measurement to date the age of the universe. The Hubble Space Telescope's instruments let us view that expansion of the universe. Here's a timeline of the universe and how Hubble's instruments help define it. Scientists believe the universe expanded from an extremely dense and hot state more than 13 billion years ago, and it continues to expand today. In 2004, astronomers unveiled the deepest portrait of the visible universe ever achieved. The 1 million second long exposure revealed the first galaxies to emerge from the time shortly after the Big Bang, estimated at about 800 million years after the beginning of time. Light from this image comes from way before the existence of Earth and took billions of years to reach the Hubble. The Hubble Deep Field image comes from a small region in the constellation Ursa Major. It was assembled from 342 separate exposures and was taken with Hubble's Wide Field and Planetary Camera 2 over 10 days in 1995. The image has been called the most important image ever taken. Light from galaxies beyond the Milky Way takes billions of years to reach the Hubble. Our Milky Way galaxy is 100,000 light years across, meaning light takes that long to travel from one end to the other. The region that Hubble observes best extends from a few light years to a few thousand light years away. Light now arriving from these objects left sometime during early human history. From Mars, light takes just a few minutes to reach the Hubble. From Jupiter, a little over a half an hour, and from Saturn, a bit more than an hour. The Hubble can observe dramatic changes on planets and their moons the same day they occur. So what has the Hubble Space Telescope meant to astronomy? Ask Ed Weiler.
I think before launch we used phrases like Hubble represents the single biggest leap in astronomical capability since people were using their eyes and Galileo started using a telescope. That was about a factor of 10 increase in resolution for Galileo over the human eye. Although a lot of big telescopes were produced since Galileo's time, there was never one single leap that big, if you know what I mean. You know, something was 50% better, 30% better, factor of 2. Hubble was taking it at a factor of 10. We were accused of overhyping Hubble's capabilities before launch. I mean, especially with spherical aberration. You know, people said, no, you guys would have never accomplished all those things you promised. Ironically, we've gone so far beyond those original promises that we forget what the original promises were because they seem petty compared to what we've actually accomplished. I mean, we used to talk about reaching the 28th stellar magnitude, which is an astronomical term. You know, we've shown we can reach the 31st magnitude, which is like a factor 6, 7, or 8 deeper into space. We are hoping to be able to see back in time to about 1 or 2 billion years after the Big Bang. We've seen now 800 million years after the Big Bang. You know, we were hoping to be able to prove that supermassive black holes exist. You know, just one. Well, we did that right after 1993 with the faint object spectrograph, M87, the galaxy. Since then, we've basically now not only shown that black holes exist, but every galaxy we look at seems to have a supermassive black hole. They're ubiquitous. They're everywhere. So to astronomy, I mean, you hear the quote, something's going to rewrite the textbooks. Let me tell you, Hubble's rewritten a lot of textbooks. In fact, you can't pick up a textbook in astronomy or even a popular book in astronomy anywhere on Earth, written in any language, whether it's Arabic or Swahili or English or French, that isn't filled with Hubble pictures. It's become the icon for astronomy.
John Grunsfeld, a member of the Hubble servicing crew, was an accomplished astronomer before he became a NASA astronaut.
The Hubble Space Telescope is more than remarkable. It has produced all of the science that we expected it would. The discovery that black holes really do exist and occupy the center of nearly every galaxy. Massive black holes, millions of times the mass of our sun. It's measured the age of the universe, 13.7 plus or minus 0.1 billion years old. Very accurate number. It's answered just so many of those fundamental questions that people have been asking about the cosmos since people were able to ask questions. From the science community perspective, Hubble is the specialist. So Hubble is the perfect partner of the very large ground-based telescopes and the radio telescopes and the other space telescopes. But it's also that specialist where you need something that has to be answered that may be really difficult to do, then only Hubble can do it.
Hubble is a giant reflector telescope with onboard instruments that capture more light than the human eye. Its importance to astronomy is beyond measure. Let's look inside and see how it works. Light enters the telescope and reflects, or bounces, off the primary mirror. The curved primary mirror focuses the reflected light toward the smaller secondary mirror. Light reflects off the secondary mirror and back through a small hole in the primary mirror where it is focused onto the focal plane and then picked up by the science instruments. Data from the instruments is sent to a relay satellite orbiting above Earth and then beamed down to a station at White Sands, New Mexico. From there, the data is sent to the Goddard Space Flight Center in Greenbelt, Maryland, where it is processed and made available to scientists around the globe. Hubble is infamous for its ups and downs, and the observatory suffered through an inauspicious beginning. Weiler was chief project scientist at the time, and he vividly remembers the day NASA engineers discovered Hubble, in fact, was in deep trouble.
I remember one specific call from Al Bogus, who was the project scientist at the time, saying, it's absolutely clear now we've got spherical aberration and there's nothing we can do about it. And it was just devastating. And for Hubble, it had to be within an accuracy of less than a millionth of an inch. The trouble is the mirror was ground. When it was ground, the curve was ground. The edges of the mirror were too much glass was ground off. Okay, so if it were a perfect curve, all the light that hit the mirror, no matter where it hit the mirror, would come to one focus, one-point focus. But because the shape was slightly imperfect, you got rays of light coming to focus at different points, which caused the fuzzy images that you saw on the early Hubble images. I also said we had a way to fix it. We had the ability to change these little mirrors in Wide Field Planetary Camera 2 with PIC 2, and that we thought we could do this, we thought it would work, and we thought we could do it by December of 1993 without any extra money. Nobody believed us because Hubble never did anything without more money, right? But we announced it. And we started out on a campaign for 3 years. We were on a mission. Nobody believed we could do it. And we just kept working toward that mission in December of 1993, which, by the way, occurred in December of 1993 on cost and on schedule. And it worked. And it was just like 3 years of hell, and here we are, nirvana finally, heaven. And it was just, that moment was as much of a high as that day I got the call about spherical aberration. You know, it's Death Valley to the top of Everest in 3 years.
Launching 6 years after the 2003 Columbia accident, NASA's last flight to the Hubble telescope is considered the riskiest. A crew led by veteran mission commander Scott Altman would be unable to seek safe haven on the International Space Station if Shuttle Atlantis suffered the same type of heat shield damage that doomed the Columbia crew. The station is located in an entirely different orbit, and the shuttle would not have the propulsive power to fly to the outpost. The astronauts will be equipped with an inspection boom that will enable them to detect damage, and NASA has developed rudimentary techniques for repairing minor cracks, dents, or gouges in the shuttle's heat shield. But Altman and his crew will not be equipped to fix more significant damage. The Atlantis astronauts would only be able to survive on the shuttle for about 3.5 weeks. Operating in survival mode, they would shut down all but essential spaceship systems to save life-sustaining electrical power. All power and oxygen supplies on the crippled craft would be exhausted within 20 to 25 days. The Atlantis astronauts and the people who work on the telescope say the risk is worth the reward. Grunsfeld is making his 3rd trip to Hubble. The self-described Hubble hugger is risking his life for the 3rd time to make certain the telescope reaches the apex of its observational capabilities.
Spaceflight is inherently risky. I mean, you have to imagine sitting on 4.5 million pounds of explosive fuel and converting all of that chemical energy into kinetic energy of the space shuttle flying around the Earth at 17,500 miles an hour. One has to imagine it's risky to go out in a cloth spacesuit in a vacuum that's lethal to humans. So why do we take these risks? Why do I take these risks? I take these risks because I think that space exploration, science, the science that the Hubble Space Telescope does is incredibly important to humanity. For the people of planet Earth, the kind of risk we're taking in the space program are worth the risk. And it's the risk that I accept as a risk taker.
A married mother of 2 from Silver Spring, Maryland, Jackie Townsend is the instrument manager who shepherded a new Hubble planetary camera through testing in advance of the upcoming launch. She agrees with Grunsfeld.
I think that the Hubble Space Telescope program is able to capture the imagination of the American people and the imagination of the people who work on the program as well, because it's so big and what it does is so diverse. There's a gee whiz factor for astronauts who get to work with the Hubble Space Telescope program, and there's a gee whiz factor for engineers who get to work with the shuttle program, and that's really great. And I think that's the same kind of thing that blending and that melding of the best that Americans have to offer, that humanity has to offer, in the astronauts and in the engineers that do this work, and the scientists who use this instrument to move us forward as a race. I just think it's just amazing.
Shuttle Endeavour would be ready to fly within a week from one of NASA's 2 Kennedy Space Center launch pads on a rescue mission if Atlantis suffers damage so severe the spaceship and its astronauts would be lost during atmospheric reentry. A crew headed by veteran astronaut Chris Ferguson would blast off on a remarkably daring and dramatic mission to rescue the Hubble servicing crew. Bound to captivate a worldwide audience if launched, here's how the unprecedented space rescue mission would unfold. First, NASA would start up an abbreviated launch countdown. Ferguson and his crew, which would include pilot Eric Bowe, flight engineer Stephen Bowen, and mission specialist Shane Kimbrough, would jet to Kennedy from Johnson Space Center in Houston and prepare to launch 7 days after Atlantis. Altman and his Atlantis crew would immediately power down shuttle systems and wait it out in a cold, dark spaceship. On board with the commander, pilot Gregory Ray J. Johnson, and 5 mission specialists: Grunsfeld, Mike Massimino, Andrew Feustel, Mike Good, and robot arm operator Megan MacArthur. Endeavour's astronauts would rendezvous with Hubble and the crippled spaceship Atlantis the day after launch. Flying payload bay to payload bay and perpendicular, Endeavour's 50-foot robot arm would latch onto a grapple fixture on Atlantis' inspection boom. The 2 orbiters then would maneuver into a parallel position. Spacewalkers from Atlantis would escort crewmates, one at a time, to Endeavour, crawling hand over hand along its robot arm to the rescue shuttle. Flying Atlantis by remote control, Mission Control in Houston would guide the crippled spaceship into the Pacific Ocean. With all 11 astronauts on board Endeavour, the joined crew would inspect the rescue shuttle's heat shield before atmospheric reentry and landing at Kennedy Space Center. The chance that a rescue mission will be required is low. The odds are about 1 in 400. So Hubble project scientists, engineers, and managers are bracing for a challenging mission that will involve 5 spacewalks on consecutive days. Top priority: install the new wide-field camera that was prepped and tested by Townsend and her instrument team. Watching on at a control room at NASA's Goddard Space Flight Center in Greenbelt, Maryland, Townsend said she is bound to get emotional once the new camera is safely in place.
I know that in the moment, I'm going to be very technical, very crisp, very focused, just like the crew is going to be, on what comes next and making sure that we do everything perfectly correctly. But the moment that it's done and it's in, I think it's going to be like watching your child take its first steps. It's going to be a very powerful and personal experience for me to know that I was part of that the work that I've done over the past 3.5 years is going to be part of history. That's really, I think, going to be very moving.
Over the course of the following 4 days, 2 teams of Atlantis spacewalkers, made up of Grunsfeld and Feustel and Massimino and Good, will install the Cosmic Origin Spectrograph. They'll attempt to resuscitate 2 other instruments, the Advanced Camera for Surveys and the Space Telescope Imaging Spectrograph. They'll install a refurbished Science Instrument Command and Data Handling Unit and equip the observatory with new batteries and gyroscopes. gear that should enable the observatory to operate at least another 5 years, perhaps a decade or more.
The amazing thing about the Hubble Space Telescope is that it has a capability to be serviced by humans and represents the best marriage between human spaceflight and robotic science spacecraft. And that marriage allows us to upgrade the telescope to give it new capability. If you look at the original Hubble Space Telescope that was launched in 1990, no one at that time could have imagined the capabilities in the detectors, the cameras that we put on Hubble, and the scientific instruments that we have available now. And that's what we're going to put up.
Once all the spacewalking work is done, Atlantis mission specialist Megan MacArthur will use the shuttle's robot arm to lift the telescope from a work platform in the ship's cargo bay and then release it back into its operational orbit some 350 miles above the planet. For Grunsfeld, it'll be a touching moment.
So here I am going back to visit an old friend to give it a new life, along with a team of some Hubble repeats, other Hubble huggers, and a new team. So I'm looking forward to that moment with some mixed emotions. But when we've successfully serviced the Hubble with all of the things we have on our plate, a very challenging mission and a very complex mission, when Hubble flies away, I'm going to be very proud of the shuttle team that allowed us to go there and of the Hubble team that has come up with all of these fixes that will make Hubble just an incredible discovery machine.
Weighing in at about 13 tons, the Hubble telescope looms 4 stories tall and is as large as a school bus. So ultimately, NASA will have to send up a robotic spacecraft to propel the observatory into a watery grave in the Pacific.
Hubble is large enough and has this huge heavy mirror that some parts of Hubble will make it down to the ground, and we don't want it to fall on a city or on a place that could do damage. So it has to have a controlled entry and it has to be a guided entry. So it goes somewhere, say, into the Pacific. When I'm asked what's my favorite Hubble picture, boy, that's a tough question. Hubble has produced so many fantastic images, but there are 2 pictures in particular that I have to consider my favorites for a very fundamental reason. And I'll tell you what the pictures are first, and then the reason. The first is a picture of the Eskimo Nebula that was taken early in the year 2000. And this is a picture of what our sun may look like someday. It's a normal star, something like our sun, that at the end of its life has started to produce these little explosions that the star that continues to burn lights up and creates something we call a planetary nebula. The other picture is called the Tadpole, and it was taken by the Advanced Camera for Surveys in 2002. And it's a picture of actually 2 galaxies that are interacting, and it has a long tail and it looks kind of like a tadpole. And it's a galactic collision. Fascinating from an astrophysics point of view. But even more so, in the background are about 6,000 galaxies, which opened my eyes to the fact that from now on, once we installed the Advanced Camera for Surveys, every picture we take would have this depth that we had never imagined before. Now, why are these my 2 favorite pictures? Because after 1999, the Eskimo Nebula was one of the first pictures the telescope took after we serviced it on STS-103, and the Tadpole was one of the first pictures that the telescope took after STS-109, proving that we hadn't broken the telescope and that it was still working.
My favorite Hubble image is actually pretty much any image of galactic collisions. When galaxies collide, I just think that is the coolest cosmic phenomenon out there. And the reason I think it's so cool is if somebody talks about galaxies colliding together, it seems like that's going to be one giant cosmic disaster. But in fact, it's a very creative process. There's very few like stars or planets that collide in that process. But what does collide as these two galaxies merge or pass through each other is all of the dust that's been blown off by the aging or extinguished stars. And as those stars are compressed, they create new stars and new planets. So what seems like it ought to be a very destructive phenomenon is in fact a creative thing. And I just think that's just as cool as can be.
I've mothered 120 children, and you want me to tell you who's my favorite child?
Yes.
I recall that there are two images that the Hubble Heritage Team took as our first images. And when I say took, it means we scheduled the observations, we planned, and we said, ooh, what's it gonna look like? And you know, if we use this filter, it might do this. And then we saw the data for the first moment that it came off the telescope. Those two objects are the Ring Nebula and the Keyhole Nebula. And there's something about those two objects that just blow me away today, even when I look at them, and I've been looking at them for 10 years. When you put all your, your efforts together and you see the fruit of your labors, and it's amazing and it blows your mind, it's inspiring. And every time you look at that thing, you're going to say, wow, we did something right. Let's do more.
Florida Today and FloridaToday.com were proud to bring you Saving Hubble, a special presentation about NASA's Hubble Space Telescope mission, which is scheduled to launch from Kennedy Space Center later this month.